Everything around you feels solid, permanent, real. The chair beneath you resists your weight. The air fills your lungs. Your hands seem made of something stable and dependable. Since childhood, you were told that matter is built from tiny pieces called atoms, and atoms from even smaller particles, little physical beads forming the architecture of existence. It is a comforting image, reality assembled from miniature objects, clicking together like cosmic machinery. But what if that picture is only a convenient story? The deeper physics investigates the foundations of matter, the less particle. Like these so-called particles become, they blur, spread, dissolve into abstractions that defy the image of a tiny solid thing. The closer we look, the less substance we find. What once seemed concrete begins to feel disturbingly conceptual. Maybe matter is not made of things at all, and if it isn't made of things, then what is it made of? At the beginning of the 20th century, physics believed it had nearly completed its map of reality. Particles were imagined as tiny billiard balls, compact, measurable, obedient to precise laws, clean trajectories, predictable outcomes. The universe appeared mechanical and reassuringly logical. Then the experiments began to disagree. Light refused to behave like a simple wave. Electrons refused to act like solid specks. Results emerged that no classical picture could contain. The rupture was not gradual, it was conceptual. The old image shattered under evidence. Out of that fracture, quantum theory was born, carrying equations that worked with terrifying accuracy. Yet even pioneers like Richard Feynman openly admitted that no one truly understands what a particle is. The mathematics predicts outcomes flawlessly. The experiments confirm them relentlessly. And still, the underlying picture dissolves when we try to describe it. We can calculate them perfectly. We cannot describe what they are. That contradiction is the beginning. Imagine firing a single particle toward a barrier with two narrow openings. Common sense says it must pass through one slit or the other, like a grain of sand choosing a path. But the results refuse that logic. The pattern that forms on the screen behind the barrier is not the mark of tiny bullets. It is the signature of a wave and interference pattern created by something spread out, overlapping with itself, not metaphorically, physically. The particle behaves as though it travels through both slits at once, interfering with possibilities rather than committing to a single route. It does not move like a compact dot tracing a clean trajectory. It evolves like a probability cloud, diffused across space, describing where it might be found rather than where it is. Our intuition demands location. Quantum reality withholds it. The particle is not somewhere in particular. It is everywhere it could be, until something forces it to choose. Left alone, the quantum world unfolds as a spread of possibilities, a haze of potential outcomes evolving quietly beyond direct perception. Yet the moment a measurement occurs, that haze appears to snap into a single result. The wave becomes a particle. A cloud becomes a point. But what does observation truly mean? It does not require a human eye. It requires interaction, an encounter that forces the system to commit. Before measurement, possibilities. After measurement, fact. The transition is abrupt, almost violent in its implications. It suggests that reality is not fully settled until something compels it to settle. Is the world waiting for interaction to define itself, or is definition itself the product of interaction? The language falters here. We speak of particles as though they are objects persisting through time, but perhaps that is the mistake. Maybe particles are not objects at all. Maybe they are events. And events don't exist the way objects do. As quantum theory matured, the picture shifted again, more radically than before. The most successful framework we possess, quantum field theory, does not begin with particles at all. It begins with fields, invisible continuous entities stretching across all of space, present everywhere at once. What we call a particle is not a tiny independent thing. It is a localized excitation of an underlying field, a temporary ripple rising from something deeper. An electron is not a marble orbiting a nucleus. It is a vibration in the electron field, the way a wave is a vibration of the ocean. Remove the field, and the particle cannot exist. The solidity we imagine dissolves into dynamic activity. Matter becomes motion. Substance becomes pattern. And this applies to you as well. Your body is not assembled from little solid beads. You are a choreography of excitations, structured fluctuations, sustained by invisible fields. And fluctuations do not have sharp boundaries. Zoom further inward, past molecules, past atoms, into the structure you were told was solid. An atom is mostly empty space. If its nucleus were the size of a marble at the center of a stadium, the electrons would flicker at the outer walls, leaving a vast interior void. The solidity you feel is not packed substance. It is distance. Even the nucleus, dense as it seems, is not a cluster of miniature stones pressed together. It is a storm of energy interactions, quarks bound by forces that never sit still. What you experience as firmness is electromagnetic resistance, fields refusing to overlap. Touch is not contact. It is repulsion. When your hand meets a table, no surfaces truly meet. Their fields push against each other, preventing collapse. The sensation of solidity emerges from invisible exchange. Beneath it all, there are no tiny pebbles holding you together. So why does anything feel real? As the emptiness of matter becomes undeniable, the role of mathematics emerges with uncanny authority. Equations capture the behavior of particles with precision that language cannot approach. In quantum mechanics, the fundamental entity is not a tiny object or a localized dot. It is the wave function, a mathematical description of probabilities, a complex object encoding all possible outcomes. We never observe it directly. No microscope or detector can capture its essence. And yet, it predicts everything, from the scattering of electrons to the energy of atoms, with astonishing accuracy. We trust the math more than our senses, more than our intuition. It works even when our imagination fails. Contrast is stark. We rely on numbers and formulas that describe phenomena beyond comprehension, while the objects we thought we understood dissolve under scrutiny. Maybe reality itself cannot be pictured, only encoded. Perhaps the world exists first in mathematics and only secondarily in experience. Particles seem tangible because we see them only during interactions. An electron in an atom does not orbit like a tiny planet, tracing a precise path. Between measurements, it does not occupy a single location. Instead, it exists as a spread of probabilities, a cloud of potential, evolving according to the wave function. What appears as a dot is merely the moment we force a decision, an encounter that collapses possibilities into a single observed outcome. This challenges the very notion of space. If a particle is not somewhere in particular until measured, what does place even mean? Is space a container holding objects? Or is it an emergent pattern of interactions defined by events themselves? The solidity and coordinates we rely on dissolve under this lens. Perhaps the world is not a stage populated by things, but a network of possibilities, constantly weaving itself into temporary realities wherever observation touches. If particles are not objects, then what truly exists are fields more fundamental than the points we once called matter. Is reality built from information, from relationships, from interactions, rather than solid things? Perhaps the universe is not a collection of nouns, but a web of verbs, a network of events unfolding in patterns we barely perceive. Each so-called particle is an interaction, a ripple in a field, a conversation between possibilities. The solidity we rely on is an illusion, a temporary manifestation of these dynamic exchanges. Contrast is unavoidable. Objects are nouns, static and bounded. Physics, however, speaks in verbs, motion, change, influence, emergence. Matter is not something you hold. It is something that happens. What we experience as existence is the choreography of countless interactions, layered and overlapping, constructing the illusion of things. They flow, evolve, and vanish in every instant. We began with certainty. Everything seemed solid. Particles were the bricks of reality, the invisible foundation beneath our feet. That certainty now feels like a memory from another world. The deeper we peer into matter, the more it dissolves. Atoms, electrons, nuclei, known are what they seemed. Solidity gives way to fields, probabilities, interactions, and waves. The physical things we imagined are abstractions, convenient shorthand for a reality that refuses to be pinned down. This is not a failure of physics. It is a revelation of our intuition's limits. Our minds crave objects, edges, permanence. The universe does not comply. Particles do not exist in the way we thought. The very notion of matter is a placeholder for events and processes. And if particles vanish under scrutiny, perhaps the world itself is not a world of things at all. Maybe nothing exists the way we think it does.